Hello, today we will continue to study tension and normal line. Okay, so we continue by solving this problem. Find the points where the curve described by the following parameter equation has a zero slope. So you need to find the points on this curve where the slope equals 0. So that means at that point the slope equals 0 of this parametric equation. And so that means this question, that means they're asking for the slope equals 0. That means derivative of this parametric equals 0. And when we set equals 0, we solve for t, and then when you get t, then you replace, you get sy, you get 2 points. It's simple, okay? So the problem right here. So we need to take the derivative of dx over dt, because this is x by t, and this is dy over dt, because this one y by t, and then you calculate dy over dx. Okay, let's go. Okay, so now we know we have not take the derivative dy over dx. Okay, but dy over dx by chain rule equal dy over dt over dx over dt. Okay, so you need to take the derivative of this dx over dt, and to take the derivative of this, and you can divide it, and you get dy over dx. Okay, and set it equal 0. This one equal 0, and so for t. Okay, when you get t, then you put it back in here. You get x and y. Okay, so let's go for that. Okay, so let's take the derivative of this dx over dt will be equal. Okay, this is a fraction, quotient. Use the fraction rule. You have the derivative of this, the derivative of the top, 3t. Okay, high derivative, or say the bottom 1 plus t cubed minus derivative of this 1 plus t cubed, this derivative times 3t, and divide by the bottom square, denominator the wanted square. Okay, so derivative of 3t equal 3 this 1 plus t square, 1 plus t cubed, and minus, okay, the derivative of 1 plus t cubed equals 3t square, minus 3t square, and multiply with 3t, divide by 1 plus t cubed upon t square. Okay, so if you take 3 in front, then you have dx over dt will equal, if you simplify 3, okay, here if you multiply it, then you have 3 plus 3t cubed and minus 3t square times 3t equal minus 9t cubed over 1 plus t cubed the whole thing square. So 3t cubed minus 9t cubed equal, okay, 3 here equal minus 6t cubed, divide by 1 plus t cubed over square. Okay, and then you can factor 3 out, and you have 3, 1 minus 2t cubed over 1 plus t cubed the whole thing squared. Okay, so this, you can stop right here and just put the answer somewhere. So here, if you put the x over dt equal, last one, 3, 1 minus 2t cubed over 1 plus t cubed squared. Okay, well, I probably need to buy a new blockball bigger than this one, too small, so I have to say the answer up there in the radius part. So now we take the derivative of this, dy over dt. Okay, derivative dy over dt equal derivative of 3t squared pi 1 plus t cubed minus 1 plus t cubed derivative times 3t squared divided by 1 plus t cubed the whole thing squared. Okay, so derivative 3t squared is 60 by 1 plus t cubed derivative of 1 plus t cubed equal 3t squared minus 3t squared pi 3t squared. Divided by 1 plus t cubed squared. Okay, so we simplify this, multiply it out, then dy over dt equals 6t plus 64 minus 94 divided by 1 plus t cubed the whole thing squared. Okay, 60, and here's 64 minus 94 equal minus 3t4. Divided by 1 plus t squared squared. Okay, 60 minus 3t4. If you factor 3t out, then you have 2 minus t cubed over 1 plus t cubed 1 thing squared. Okay, so we can stop right here. Okay, so that's dx over dx over dt, and here dy over dt. So if you take dy over dt divide by dx over dt, then you get dy over dx. Okay, so I keep the answer right there. Write this part. So let's say we calculate dy over dx. We will equal dy over dt divided by chain rule dx over dt. Okay, well, this the right hand side is equal to left hand side. If you cancel dt will be equal. Okay, then we will equal dy over dt. That's 3t 2 minus t cubed over 1 plus t cubed the whole thing square and divided by dx over dt. 3 1 minus 2t cubed divided by 1 plus t cubed the whole thing square. Okay, so here you have 1 plus t cubed the whole thing square, cancel with this, and 3 cancel with this. Then we have like, so finally we have dy over dx will be equal t times 2 minus t cubed divided by 1 minus 2t cubed. Okay. Okay, that's right. So we can, okay, so now we need to set dy over dx equal 0 because slope equal 0. Okay, so let's write this part. So dy, so we set that dy over dx equal 0, equivalent with last t times 2 minus t cubed over 1 minus 2t cubed equal 0. Okay, equation has the 0 slope. Okay, so that means derivative equal 0. Okay, and when we set the 0, this one is quotient, fraction equal 0, quotient equal 0, then numerator equal 0. So that equivalent with t 2 times t cubed equal 0. So that means t equal 0 or 2 minus t cubed equal 0. Okay, this one t cubed equal 2, so that means t equal, take square root both sides, t equal 2 to 1/3. Okay, so we have t equal 0 or t equal 2 to 1/3, and you substitute in here to x. So as t equal 0, so let's say t equal 0, we have 2 points, so t equal 0, then at t equal 0, and substitute here, then s equal 0 times 3 0, 1 to 0, s equal 0, and t equal 0, t equal 0, the y also equal 0. So the first point A, let's say point A has 0 0. B, t equal 2/3, and s equal, we should put in here, 3 equal 3 multiplied by 2/3. Okay, and 1 plus 2/3, 2 to 1/3, 2 cube, okay, 3 times 2, and 3, and this one cancel, 2 to 1/3, and the whole thing power 3 and equal 2, 2 plus 1 equal 3, 3 cancel 3, so I equal 2 to 1/3 or cube root of 2. Okay, so Okay, I'm out of space, so we know that at second point ft equal to 1/3, then s equal 2 to 1/3. Okay. S equal 2 to 1/3. How about y? So substitute 2 1/3 over there. At t equal 2 to 1/3 over there. Then at y equal 3 by 2 1/3. The whole thing square. Divide by 1 plus that. 1 plus 2 to 1/3. The whole thing cube. Okay, so here you have 3, 2 times 2/3 divided by this one equal 3, something 2 to 1/3, 2 power cube equal 2, 2 plus 1 equal 3, and 3 cancel 3 equal 2 2/3. Okay, so as t equal 2/3, then s equal 2 1/3, and y equal 2 2/3. So we have the second point. Okay, y equal 2 2/3. So the second point will equal 2 1/3 and 2 2/3. Okay, so that's the answer. This point and then this point. So at point A 0 0 and at point B 2 1/3 and 2 to the 2/3, then the curve of this parametric equation will have 0 slope. Okay, so we have 2 points. Okay, so I think this is a good place to stop, and we will continue one more problem for tangent and normal line in the next video. Alright, so just practice and do your exercise, and I think you will get this chapter easily. Tangent and normal line. Okay, tangent and normal line, perpendicular. So if you find tangent, then you can find normal line. If you have normal line, you can find tangent. So if the question asks tangent and something related to normal line, then you can find something from tangent and vice versa. Okay, alright, see you next time.